Welcome to Maths with Bob. Today we're looking at absolute value, and we're continuing on with example 3 and creating a double absolute value inequation actually. And you can see the purple graph is the one which actually drew from the previous example by drawing the y equals the absolute value of 2x minus 5 and y equals the absolute value of x plus 2 and trying to add them. But basically what happened is there were a couple of critical values, minus 2 and 2.5, and if you like, let's actually have a quick look, although this doesn't line up terribly well, but over here, in fact, it's supposed to look like minus 3x plus 3, that purple arm going up. Okay, now in between here and here, this graph in here, that is supposed to look like y equals minus x plus 7. And if I go over on the other side over here, that purple arm going up that way looks like y equals 3x minus 3. And we found that by adding arms of different parts of the different absolute value graphs, some of them positive and negative arms depending on what section of the domain I was in. And we ended up getting solutions. I need to also put the solution in. We can see the solution when it was equal to 7. You can see here the solution down here was 0, down there, and 3.5. Now, let's have a look. How am I going to interpret this one? That the sum of the graphs is less than 7. Well, if you have a look, there's only a little bit of it, which is just this little bit around here. Okay, that little bit around there is actually below 7. So the solution, obviously, would be, in fact, if I drop it down onto the x-axis down here, the solution would be around here. Okay, so the solution, we can have a quick look at and write. Okay, what is the solution? Well, these are the values here we need to look at. So let's have a look. What are they? 0 and 3.5. So let's actually write the solution. So the solution to this one would be what? Okay. Now the solution to this inequality, well, we can see that the sum of those two graphs drops below 7 in between x is 0 and 3.5. So the solution would be x such that, okay, x, now it's less than, so it's 0 and 3.5. Okay, so that would be the solution to that. Now, you can see this relies on us being able to draw the graph, the combined graph, that purple one, of the two original absolute value graphs. Okay, so let's now switch that absolute value sign around and see what the solution would be then. Okay, well, I'll switch the inequality symbol around to greater than or equal to 7 now, and if I look at the graphs, where is this occurring? I guess you could say for what x values is the sum of those two absolute value curves above 7? Well, there's a couple of arms. There's this bit over here, you can see over here. It's over there. Okay. And there's another bit over here on this other side over here. Okay, there's a bit over there too. Okay, so we can see that we actually have a couple of arms which satisfy this. So how are we going to write this in terms of the solution? Well, we look at the x values and we can see, okay, that arm is above 7. This one over here. Okay, this one over here. This one is actually above 7 when x is greater than 3.5. So we can just write that in terms of solutions. Okay, let's actually write like this. X such that, now x needs to be greater than or equal to 3.5 in this case, and comma. Now where is the other one? Well, if we have a look, we can see that this is the arm we're after over here, and that's and actually, okay, hold on, and we can also have this bit of the arm around here as well. So okay, that's above 7 as well. So you can see that as long as x is less than or equal to 0, that arm will be sitting above 7. Okay, so also let's write that in as well. Okay, x is less than or equal to 0 as well. So the solution is now basically on the other side of these two x values as it was in the previous example. Okay, well, thanks for watching, and as you can see it's a bit messy and complicated, but if you can actually draw the addition of those graphs, you can see that you can actually do all sorts of different problems with them. Thank you for watching. Bye for now.